So today we are doing volume of a prism. We've been touching on surface area for the past two lessons, and volume is probably, in my opinion, easier than it. Yeah. Oh. God. Tablet mode. There we go. So surface area talks about how much is outside of the shape, how much is on the outside. So remember, the surface area is the sum of the area of all the external faces added together. Now when we're talking about volume, volume refers to all of the amount that's inside the shape. Volume refers to how much space is inside the shape. So surface area talks about the area of all the external faces of the shape. The volume talks about how much space is inside of a three-dimensional shape. It's defined by the number of cubic units within a three-dimensional object. Oh, hold on, what is happening here? Backspace, please. Contained within a three-dimensional object so it's how much space amount is inside of an object. To convert between units, so this is probably an important one. So let's just talk about our normal conversion of units. We have millimeters, we have centimeters, we have meters, and then we have kilometers. They're probably the only ones we're going to talk about too much. And then we can convert between all of these. And then that's going the other way, that's going the other way, that's going the other way. So can someone remind me, how do I get from millimeters to centimeters? 10. Do I multiply or divide? If I have 10 millimeters, how many centimeters do I have? So I'm getting smaller in terms of the amount, so I divide by 10. Centimeters to meters, divide by 100. And then divide by 1,000. If I divide by 1,000 to go one way, how do I go back the other way? I times by 1,000. So these are all going to be times. And then the same numbers that we have at the top. Now this is the important part. So we've only dealt with units so far, so millimeters, centimeters, meters, kilometers. Well, if I cube all of them, so now I want to go from millimeters cubed to centimeters cubed. What would I have to do to this 10 here, Matthew? I have to cube it as well. So if we cube our units, we also have to cube our conversions. Millimeters to centimeters is usually divided by 10. Well, if it's millimeters cubed divided by centimeters cubed, you have to divide by 10 cubed. And that is how we go between units if we have volumes of different amounts. We also need to talk about capacity. So for capacity, volume and capacity are often linked together. Volume talks about how much space is inside of a three-dimensional object. Well, we kind of think about that as solids. Capacity, we can kind of think of it as liquids, as milliliters, as liters, right? And so when we're talking about capacity, measured in litres or millilitres, it's important to remember I like to call it the golden ratio. It's not the golden ratio, but it's just what I call it. One centimetre cubed equals 1 milliliter. 1 centimetre cubed is equal to 1 milliliter. So if you have the volume of an object, to say it's 100 centimetres cubed, that means you can put 100 millilitres worth of liquid into that space. The volume of any prism is the cross-sectional base, the area of the cross-sectional base times the height. Okay, and as a formula, you'll often see it as just like area of B times height. And when I say this AOB, that's area of base. So the area of the base times by the height. So tissue box, right? Looking at it from that way, what shape is consistent the whole way throughout? The rectangle, right here. Okay? To find the volume of this, I would find the area of this face right there, and then multiply it by how much I go across. Area of the cross-sectional base times by the height. And then we'll show the widget that we've got up here. So let's talk about this one. So which face is the same shape throughout? That L-looking shape. So we need to find the area of that L-looking shape. Area of that is just going to be 8 centimeters cubed. We can figure that out in other ways. They just used the grid to figure that out. Oh, sorry. Just did that at the same time. So the volume of that, and then we times it by the height, which is 5 centimeters, because that 5 centimeters is how tall we are. You can also see it this way, where they cut it into 5 sort of slices, and then they just find out how much is in one slice and times it by 5. Different ways to think about it, but it's always the area of the base times the height. So we're just going to do a couple converting examples, and then a couple of volume examples, and then get into some questions. So we want to do 2.5 meters cubed, and I want to convert that to centimeters cubed. All right, well, the first thing I need to think about is how do I get from meters to centimeters? What do I usually do to get from meters to centimeters? Lena? Oh, okay, yep. Mark, how do I usually get from meters to centimeters?
Multiply it by 100.
Yeah. I always try and think about it in my head. So like if I have 1 meter, how many centimeters do I have? Well, 1 meter is 100 centimeters, so obviously I need to multiply by 100. Well, if now we're saying it's cubed, we have to cube that conversion rate as well. So we're timesing 2.5 by 100 cubed, which gets us to 250,000 centimeters cubed. Again, this is probably quite basic and you're probably a little bit bored right now, but we really need to get this trick quite good, because if you ever have a conversion of unit questions, they're easy marks that you can just check off straight at the start. Lice?
I was going to say, would there be like a lot of those questions?
No. Like in terms of just converting units, you might get, it's a very common first question in tests.
Oh, yeah. I mean, like at the end, we have to like convert, you know, after we like do all the working out, like that question.
Sometimes. It may be like, say your answer in meters cubed and you've only got it in centimeters. And so it's just common to like change it at the end. Find the volume. So first one we're going to have oh, look at that. Perfect. Not so much. Okay, this got bad fast. Okay, so that's 3 meters. That's 4 meters. And that's 9 meters. So let's just start with the formula. Volume is always equal to the area of the base times the height. Well, what is the base of the object? What is the area of the cross-sectional base, the shape that is the same throughout the entire prism? Matthew? 6. How do we get 6? Because it's the area of the triangle. So it's half base times height of the triangle, and then times that by the height of the prism, which is going to be 9. So I'll just write 9 in and show how I got there. Well, 3 times 4 is equal to 12, and then half of that is 6. So we've got 6 times 9, which equals 54. 54 what? Meters cubed, because we're in meters and we're measuring volume. B. Now got a rectangular prism. So that's 8 centimeters, 6 centimeters, 4 centimeters. Now we know the volume, again, area of base times the height. Quite luckily with rectangular prisms, because of the nature of the shape, it really doesn't matter in what order we do these. We could have that front face is the same throughout, the side face is the same throughout, the top face is the same throughout. It's kind of weird and can do it in several ways. So this really is just equal to length times width times height. You just multiply the 3 numbers that you have together. And it's always going to be the same number at the end. So you got 8 times 6 times 4. That gets me to 192 centimeters cubed. Alright, so when we have rectangular prisms, they are quite easy because it is literally just the 3 numbers multiplied together. Other ones are a little bit more tricky because you actually have to figure out the individual areas of the base. You have any questions? Anything at all? Alright, for those watching at home, we've got the questions and I'll put them up at the top of the page at the end of this